Okay, our notes today are called adding, subtracting, and multiplying polynomials. If you'll please title your notes as the same, and I was lazy, so I just put the signs. Adding, subtracting, and multiplying polynomials. Yes, you may. Okay, essential question today. How is adding and subtracting polynomials different than multiplying polynomials? Yes? Hey, that one's not plugged in, so we'll use the one in the back. The section number comes from 4-2, 4-2. Is that what you wanted to know in the book? Yeah, this one's 4-2. Does that help if we put it on the notes so you can flip to the book? This one comes from 4-2. Okay? So our central question. How does adding and subtracting polynomials can I fit? Barely. Differ from multiplying polynomials? That should actually be a question mark. Okay, when we solve equations, adding and subtracting have similar behaviors because they're inverses of each other's. And multiplication and division also have similar behaviors because they are inverses of each other. So the way we add and subtract is different sometimes than how we multiply and divide. For instance, fractions. How do we add and subtract fractions? What do you have to have? You have to have a common denominator before you can add and subtract fractions. But do you have to have a common denominator when you multiply or divide fractions? No. So their behaviors, add and subtract have similar behaviors. Multiplication and division have similar behaviors to each other, but different than adding and subtracting. So the same thing is going to happen in polynomials. Okay. Okay, there we go. Okay, we're going to start with adding and subtracting. Example 1, let's see. I need a trinomial. You can be creative. Would anyone like to give me a trinomial? Tri means it has 3 terms. Trinomial. Tyler? Okay, let's give it a variable. How about m cubed? It has to be the same variable. Okay? Okay. Lots of 5s in there. That's our trinomial. Plus, let's see. How about 7m to the 15th minus 2m squared plus 13. Okay, when we add and subtract polynomials, all we really have to do is find like terms because nothing really changes these terms. In front of this parenthesis right here, between the plus and the parenthesis, there's actually a number here, and it's not going to affect this at all. We have actually a positive 1. Does timesing 7m to the 15th by positive 1 change 7m to the 15th? No. So we can just drop all of the parentheses in adding. We don't really need them. And then we can look for, like terms. So I'm just rewriting it. I dropped all the parentheses and we look for like terms. Louisa, can you find any like terms up there? So they have to have something in common to be like terms, right? You have to tell me the whole term, because we have here 6 terms. So 5 isn't actually written up here. There are 5s, but they have something else with them. Oh, okay, I didn't hear that. So 5m to the 15th. What's its like term, Lisa? Yeah, because these are like terms because they both have m to the 15th, right? Oh, epiphany. Ooh, mind blown. I like, you know those commercials where that guy sits at a table with little kids, and then the kids say silly things, and he's like, mind blown moment. Yeah, does that make sense, Gucci? Yeah. Okay, Gucci, how about you find us another pair of like terms?
5 and to the third power 13. No, that's not. Okay, my bad. Continue to roll on. 5 and 13. Alrighty. Just go ahead and do you.
You know why it's so hard, Gucci? You know why it's so hard? It's because we don't have any more like terms. See, they don't have it anymore. This is m cubed, this is m to the first, this is m squared, this is m to the 0. So that's why you're having a hard time, is because there are no more like terms. So we can go ahead and put these together, and let's write it in standard form. Standard form means we're decreasing in power, so we need to write the 15s first. 5 plus 7, Eric. How many m to the 15s do we have? 12 m to the 15th power. Okay, then we have to write the next power in line. Noah, what's the next highest power? The cubed. And this is positive 5m cubed, so we put plus 5m cubed. Okay, Adam, what's the next highest power? Ah, good. Minus 2m squared. This is a common mistake that people don't see the minus, so good job. It is minus 2m squared. Okay, Macon, what would come next? Plus 5 what? Plus 5m, good. And then we have our constant plus 13. So this is standard form, and we've added them together. Any questions on number 1? Okay, let's try a subtraction then. Okay, let's see. How about Selena? Would you mind giving us a polynomial, a trinomial like, I don't remember who gave us that one to us earlier. A trinomial has 3 terms. Oh, Tyler gave it to us last time. So Selena, can you give us another trinomial? N as in Nancy. Okay, 6n squared. And you can change the number too. They don't all have to be 6s. Okay? Okay, that's good, because that's a trinomial. It has 3 pieces. Okay? Minus, let's see, how about 12n squared minus 8n plus 11. Raise your hand if you see what's different about example 2 than example 1. Okay, one person's noticed. Put it out if you notice what's different between example 1 and example 2. What has changed? Take a close look if you don't have your hand up. What has changed? Okay, Allison, what's changed? It's a subtraction problem. Good, we're subtracting a polynomial. So, can I just drop the parentheses and write all the terms out like we did on the last one? No, who can tell me why? Silver? What kind of 1 is right here? A negative 1. And why does that matter?
Because if you multiply a negative by
Okay, it's going to affect the signs of everything. So we have to distribute this -1 into our second trinomial. Before, we just distributed it and didn't do anything, so that's why we didn't really focus on it. But we did draw the 1 in there, and times it by +1 didn't change anything, but here stuff changes. Okay, so Cassidy, if we do -1 times 12n squared, what do we get? -1 times our first term, 12n squared. -12 n squared. Good. Okay. Alejandra, what about the next one? -1 times negative. Notice that's a negative 8n. That's not Alejandra, is it? Fernanda? Okay. Is there an Alejandra in this class? We've called 2 people out today. There's Alejandro. Okay. Fernanda, I called, yeah. Good, positive 8n. So it just changes the sign. So -1 times 11 makes that -11. It only affects the second polynomial. So the first polynomial, let's write down again. The first polynomial, we're going to write down again. Okay, Nathan, what do we do now? Okay, combine like terms. What do we have like terms? Good. I'm glad you guys are all noticing that this guy right here is a negative 12n squared. Okay, so watch out for the negatives. Emmanuel, what do we get when we combine those two? Look carefully.
Oh, -6.
Good. -6n squared. All right. Lacey, are there any other like terms? Look carefully, there are. 6n. What's the like term with 6n? What else just has an n? 10n. And what? Good, so she's called. There's 3 of them this time. Right? So 6 plus 10 is 16 plus 8. Show me with your fingers up in the air. What's that? What's 16 plus 8? What is it? Oh, can you even do that with your fingers? Does that work? 24, I see. 16 plus 8? Yeah, 24. And then does -11 have a like term? No. So, and we've written this in standard form because it's decreasing in power. N squared, n to the first, n to the 0. The -11 is actually n to the 0. Okay, any questions about adding and subtracting? Okay. Sounds like you guys have pretty much done this before, so that's a good sign. After the notes. Okay, now we're going to do a multiplying polynomials. Okay, example 3. I need a binomial. Tyler? That's 2. Mm-hmm. Okay. Oh, wow. You like to make our life hard. Okay. That's only 1, though. That's a monomial. I need another term. Plus or minus. /50th? Okay, I'll make the next one a little nicer so our lives aren't so miserable. Because if we have 2 bad ones, it's going to be really miserable. But thanks for being creative, because the other class was like 1 plus 1. Like, it was really boring. So, thanks for being creative. Okay, how about this? Yeah, we'll just do it that way. 3 times 3m cubed minus 2m. Okay, multiplying. Multiplication behaves differently than addition and subtraction. Okay? Raise your hand if you can tell me how we go about doing this problem if we're supposed to simplify it. Arbor? Yeah, so, oops, I didn't want, it's the center hat thing, exactly. Does anyone know what the real definition's called? It's called, oh, I heard it over here. A distribution. We're distributing, and this one's actually going to be a double distribution. Okay, so let's start with the 15m to the 20th power. We're going to distribute it over. So, I try to make this not so awful. Okay, so let's make Tyler do this, should we? Yeah. Because he gave it to us. Okay, Tyler, what's 15m to the 20th times the first one, 3m cubed? I don't think you need a calculator for this. What's 15 times 3? That's a standard one we do often. Oh, I'm thinking, yeah, 15 times 3. It's not too bad. So 3 15s. 15, 30, 45, okay? And then m to the what exponent, Tyler? M to the what exponent? We need to do m to the 20th times m cubed. Did we do the song in here? And when we multiply, when dealing with these exponents, is that secondary math? Who had me last year for math? Eric did. You remember the song? When dealing with these exponents and the base is the same, we got some rules, we ain't no fools, and we ain't playing games. When we multiply exponents, we multiply. What is it, Eric? Can you remember? Multiply. Oh, we learned it. Okay, what do we do with these two exponents? I heard it over here. Add. So the song goes, when we multiply exponents, we add. Multiply, add. And when we divide, we have to subtract. You missed out. It was fun last year. Okay. So 20 plus 3 is 20. Okay. And let's move over to Austin. Can you do the next one, Austin? 15m to the 20th times, notice, negative 2m. What would we get with that? Negative 30 what? To the? Yep, 21st power. Okay, now we've finished distributing 15m to the 20th. Now we have to distribute this one. Now, why is it not 28m to the 50th that we times in? And it's a negative. I heard minus as well. So make sure you catch that sign. You have to take it with it. So, let's see. Nui. Negative 28m to the 50th. What's that times 3? M to the 3rd. I chose you because you have a calculator to do negative 28 times 3. Negative 84. Good. M to the 53rd power. Okay, and who has the last one? Arbor's all over this. He's like volunteering for everything today. Okay, Arbor's the only one with it. What is it, Arbor?
Plus 56.
Okay, great. Now, at this point you have to check and see, are there any like terms to combine? No, all the exponents are different. So the final thing is, let's just write it in standard form. So tell me what I'm doing wrong when I write this. Look carefully. I've made a mistake on purpose. Make sure you capture the sign. Good job. The 84 is negative, so that means it stays negative. So here is our answer. That's a really intense one because we had such large numbers. Okay, we're just going to do one more and we'll be done, and then we can spend the rest of the time on your assignment, which isn't too long actually. And I'm going to make this one up to make sure it's not, because I would like one with some like terms. Okay, let's just do 7k minus 2 times negative 4k plus 8. Okay, and you've already seen how it's done. Actually, nope. k squared, k minus 1. Okay, trinomial. Binomial times the trinomial. You've already seen pretty much how it's done, so I want you to try this problem. Now remember, each term in the first binomial needs to be multiplied to everything in the trinomial. So the 7k is going to be times 3 times, because the second parenthesis set has a trinomial, and there's 3 pieces. So multiply it out. Distribute. Sorry, no, we'll be back. So make sure you're taking that 7k to all 3 pieces. And then the minus 2 to all 3 pieces. Okay? Whoever finishes first, I'd like you to come up to the board. You can bring a paper if you need to. And write the solution with the work. And our friend Arbor, he's all over this today. He's going to do all the work too. Uh-huh, that's right. K to the 3rd power. What if you had a problem that was k to the 5th times k squared? What would it become? K to the 5th times k squared? To the 7th, k to the 7th. So make sure, because I think there's a couple in your homework that you'll have some larger exponents like a 7. So let's see how he's doing. Check your work and check what he's doing. And we'll give him a thumbs up or a thumbs down in a minute. Okay, when you finish that line, Arbor, stand to the side so we can check your work. And okay, everyone check his work. Give him a thumbs up because it's perfectly correct. The medium if there's something slight he needs to change, or thumbs down if it's all wrong. Thumbs up, medium, thumbs down. Put it up high so we can see. Check it out. Thumbs up, medium, thumbs down. Put it up high so we can see. Thumbs up, medium, thumbs down. Okay. I'm actually going to go with a medium. I see 2, on the very first blue line, I see 2 slight errors. Okay, so take a look, Arbor. If you noticed one of the 2 errors, there's a hands. Noah looks like he might have found it. Noah? 7k times the positive 8k. Should that be positive 56k squared?
Oh, I wrote it wrong on my paper then.
Oh, okay. Okay. All right. Okay, there's one more. Step to the side. Yeah, you'll just erase that bottom line. Yeah, because we'll have to start over on that. Okay, Silver has her hand up. Silver, do you have the other one? Yeah, so that might have, yeah, so that's negative 16k. Yeah, erase it. And the 8k is a k squared. 8k squared, because you erased the exponent. Okay. Plus, yeah, that should be right now. Go, G. Okay, step to the side, give them a thumbs up. Is the final answer right now? Medium, because something needs to be changed. Or thumbs down. Thumbs up, medium, or thumbs down. Put it up high so we can see. Yeah, I'm going to agree with everyone else. I give you a thumbs up. Good job. Thank you, Arbor. Everyone give them a round of applause. Good. Okay, so that's what we're doing today on our assignment. And your assignment is pages 680 through 682 in your workbook, and you can write right in your workbook. So, once you've written down your assignment, I want everyone to... Nope, that's secondary math 2's assignment. I'm sorry. Don't worry, yours is shorter. 251 through 253, because there's only like 14 problems, I think. 251. Open your books to 251. So this means every problem on 251 through every problem all the way through the end of 253. So the whole page on 251. Then we flip it over, and you're doing the whole page on 252 and the whole page on 253. So does that mean that you skip the ones that say got it? No, it means you do all of them. You do the got it, you do the ones that are numbered, and the ones that have an A, B, and C. You do all of them. All of them. So even though it's 3 pages, because there's only 4 problems or 6 problems on the page, it's really not that many. I think it's 14 in total. Okay, so start on number 1. On page 251, writing right in your workbook. Okay, on page 251, it says find each sum. Okay, so we know sum is the answer to an addition problem. So you're adding. Okay, any questions about your assignment? Yeah, do you have a hall pass to give me? So this